Okay guys, welcome back to my lesson. For today we will study about trigonometric function, especially trigonometric function part 1. Before we begin the lesson, we will revise the 10th grade trigonometry. The first is trigonometry ratios in a right triangle. As you can see, in a right triangle we have opposite sides, hypotenuse sides, and adjacent sides. For the trigonometric ratio itself, we have sine, cosine, and tangent. The formula for sine is opposite over hypotenuse. The formula for cosine is adjacent over hypotenuse, and the formula of tangent is opposite over adjacent. Next is the additional trigonometric ratios, which is cosecant, secant, and cotangent. For the cosecant, it's the inverse of sine, so the formula also the inverse of sine. If the formula for sine is opposite over hypotenuse, the formula for cosine is hypotenuse over opposite. For the secant, it will be hypotenuse over adjacent. For the cotangent, it will be adjacent over opposite. You already learned this in the 10th grade, so I will not explain further. Next is trigonometric ratios of special angles. We have 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, and also 37 degree and 53 degree. And the values of sine, cos, and tan is already filled in the table shown. Okay, for this one I want you to memorize the formula, and not the formula, the value of each of the trigonometric ratio, yeah. For sine 0 degree, sine 30 degree, sine 45 degree, 60 degree, 90 degree. But for 37 and 53 is only the additional value, so you don't have to memorize it. And also for the 37 and 53 degree, the value is only the approximate value, yeah, not the actual value. Okay, so in this section I want you to memorize this, yeah. Memorize the value of the sine, cos, and tan. Okay, let's go to the next one. Next is trigonometric ratios of any angles. Okay, so for this one, we'll use the quadrant in Cartesian, which is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The area of the first quadrant will be this one, in between of x positive and also y positive. The second quadrant will be right here, the third will be right there, and the fourth will be right here. Okay, let's go to the next one. So as you can see above, we have 4 quadrants. Each quadrant gives different sign of values for trigonometric ratio. In the first quadrant, as you can see, the value of x is positive, the value of y also positive, and the value of r will be positive also. So for the sine, which is opposite over hypotenuse, the formula will be y over r, which is positive divided by positive. That means the value of the sine will be positive. For the cos, it will be adjacent over hypotenuse. The adjacent is x, which is positive value, and the r, which is the radius of the circle, which is positive value also. So positive divided by positive will be positive value. That means the cos alpha will be positive also, and the same rules apply to the tan alpha. So all of the trigonometric ratio in the first quadrant has positive value. How about second quadrant? In the second quadrant, as you can see, the value of x is negative because we are dealing with negative x-axis, yeah, negative x-axis. So the x will be negative. That means the value of cos will be negative because the adjacent is negative x. Negative x divided by the radius will be negative value. And also for the tan, opposite over adjacent, the formula is opposite over adjacent. That means the y over negative x will give us negative value also. But for the sine, it's still positive value, yeah. So in the second quadrant, only sine has positive value. Using the same rules, we can say that in the third quadrant, only tan has positive value, and in the fourth quadrant only cos has the positive value. So if we summarize the calculation, we'll have these values of trigonometric ratios in the four quadrants, and I want you to memorize this. In the first quadrant, all of the values will be positive. In the second quadrant, the sine will be positive, the third tan positive, the fourth cos positive, and also the range of the angle. For the first quadrant, the range of the angle will be 0 until 90 degree. For the second quadrant, the range of the angle will be from 90 until 180. For the third quadrant, the range will be from 180 until 270. At the fourth quadrant, it will be 270 until 360 degree. And then I want to teach you how to calculate trigonometric ratios in any angles. So first, find the value of sine 150 degree. So we already memorized the special angles, right, which is 30 degree, 45 degree, 60 degree and 90 degree. So we have to relate this 150 degree into with the special angles. So I can say that sine 150 degree is equal to sine let's say 180 degree minus 30 degree. So the idea is to use the benchmark. The benchmark is the value of angles for the axis, which is 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. But I want to tell you that if you don't if the question didn't tell you to use which benchmark, I suggest you don't use the 90 and 270, because it will be a little bit difficult if you use the 90 and 270. So for this time, just use 180 and 360. So the benchmark is only 180 and 360 for this time. Later we will learn how to use 90 and 270. Okay, so I can change the 150 into 180 minus 30 because I choose the 180 degree benchmark. You know why? Because 150 degree is right here. The nearest benchmark is 180 degree. If you use 360 degree, it will be a little bit too far. So you have to choose the nearest benchmark with the angles. 180 degree is nearer to 150 degree rather than 360 degree. So we will use 180 degree. Next, we will consider the value of the question. The question says sine 150 degree. 150 degree is in the second quadrant, right? In the second quadrant, the value of sine will be positive. You still remember? The first quadrant will be all positive. The second quadrant will be sine positive. Only sine has positive value. So this one will be positive, equals to positive, and then after that you can ignore the boundaries and not the benchmark, and then you will write sine 30, and the value of sine 30 in your table is half. So I can say that sine 150 degree equals to half, positive half, because it's in the second quadrant. There you go. That is how you calculate the value of trigonometric ratios in any angles, related with the special angles. Next is example 2. For example 2 is the same, but this time it's cos 150 degree. So for this one, I will rewrite the question first. Cos 150 degree, we can rewrite the 150 degree as 180 degree minus 30 degree. Yeah, so the relation between 150 and 30 is 180 minus 30, and we use 180 because 150 is lies in second quadrant, in the second quadrant. That means the nearest benchmark is 180 degree, so therefore we choose 180 degree. And also the value of cos in the second quadrant is negative, so I will write the negative first, and then we can ignore the 180 degree because the special angles is 30 degree. That means negative cos 30 degree, and negative cos 30 degree equals to negative half square root of 3. So the answer for cos 150 degree is negative half square root of 3. Next is tan 300. For tan 300, we will use the 360 degree as the benchmark because 300 degree lies in the fourth quadrant. That means the nearest benchmark is 360 degree. So I will write it as 360 degree minus something equals to 300. That means 60. And we know that tan in the fourth quadrant will be negative. That means I will write down the negative first, and then I will ignore the 360 degree. That means I will write it as tan 60, and also ignore the negative sign right here. Yeah, so negative tan 60 in the table, tan 60 equals to square root of 3. So the value of tan 300 degree equals to negative square root of 3. And then next is this one, sine 240. Let's calculate the sine 240 first. 240 lies in the third quadrant. Sine in third quadrant will be negative. That means sine, I will write it as 180 plus 60. So it will be sine 60. Negative half square root of 3. Okay, so sine 240 equals to negative half square root of 3. How about tan 120? Tan 120 degree equals to tan, open brackets, 180 minus 60. That means this one lies on the second quadrant. Tan in the second quadrant is negative, and then we can ignore the 180, so it will be tan 60 equals to negative square root of 3. How about cos 330? Cos 330, I will be quick for this one. It will be positive because it's in the quadrant, the fourth quadrant, and then we use the 360 as the benchmark. That means it will be cos 30. Cos 30 equals to half square root of 3. Okay, let's calculate it altogether. We have negative half square root of 3 square plus tan square means negative square root of 3 square over half square root of 3. Negative become positive when you square, and then this one is 1 over 4. Square root of 3 will become 3. When you square it, this one will be positive 3 over I will write it as square root of 3 and then multiply by 2. Okay, so we have 3 over 4 plus 3 over 1 times by 2 over square root of 3. Let's make the denominator equal. So we will have 12 over 4, 15 over 4, 15 over 4, sorry, oh yeah, 15 over 4 times 2 over square root of 3. In math, we know that we cannot leave the square root at the denominator, so we have to rationalize it like this, and then the result will become 15 over 2 square root of 3 over 3, and then you can cross out the 15 and 3. You'll have 5 over 2 square root of 3. So this is the final answer. Okay, next is example 5. For example 5, given that the value of sine alpha equals to 2 over 3, that means we have to prepare the other trigonometric ratio first by creating a right triangle like this. This one is alpha. The formula of sine is opposite over hypotenuse. That means the opposite is 2, hypotenuse is 3. The adjacent will be square root of 3 square minus 2 square using Pythagoras theorem. That means you will have square root of 5. And then let's prepare the the question wants you to find the value of cos alpha and tan alpha, yeah. So we don't have to prepare anything because the preparation is also the question. Cos alpha equals to, the formula is adjacent over hypotenuse. That means the adjacent is square root of 5, the hypotenuse equals to 3. But because the question says alpha is an obtuse angle means the angle lies in the second quadrant, and the value of cos in the second quadrant have to be negative, so we will put negative right there. And then how about the tan alpha? The tan alpha equals to opposite over adjacent. That means the opposite is 2, the adjacent is square root of 5. And then because it's an obtuse angle, the tan will be also negative. We cannot leave it like that, so we have to rationalize it. That means the final result is just like that. Next, now I want to teach you how to use 90 degree and 270 degree as our benchmark. I want to visualize first what is the difference between 180 degree and 90 degree as a benchmark. Okay, as you can see, we have alpha right here. The triangle will be like that, and then if I have 180 degree minus alpha, the triangle will be similar for the value of x and y. It's the same. The difference will be only the sign. For the x it will be negative, for the y it's still positive, yeah. Okay, I mean that the opposite sides it's still y, and this one also the opposite sides it's still y, yeah. But let's compare it with the 90 degree as the benchmark. If the alpha is right here and the opposite sides is y, when you have 90 degree plus alpha, the triangle will be a little bit different with the previous one. For this one, the opposite sides will be negative x, not y anymore. It means there are a little bit difference between the original triangle and the 90 plus alpha triangle. Yeah, the difference is the x and y is flip, swap like that, yeah. Because the x and y is swap, that means the value of sine and cos will be swapped also. That means if you use 90 degree or 270 degree as your benchmark, you have to change the trigonometry ratio as the following table. Sine will be changed into cos, cos will be changed into sine, tan will be changed into cotangent, and also this one, cosecant will be secant, secant will be cosecant, cotangent will be tangent. That's why I told you before that if the question didn't ask you to use 90 degree and 270 degree, you should choose the 180 and 360 degree as your benchmark, because you don't have to change anything if you use 180 and 360, yeah. And how to solve the problems when you use 90 and 270 as the benchmark. 150 degree lies in the second quadrant. That means the nearest benchmark is 90 degree. So I will think like 90 plus what degree equals to 150, and I got 60. Yeah, and then like usual you have to prepare the sign first. Sign in the second quadrant will be positive, so I will write the positive first, and then I will ignore the benchmark, and then I will write the 60 degree right there. But do not forget that when you use 90 degree as the benchmark, the sign have to be changed into cos. This step usually forgotten by students because they usually do the elimination of the benchmark, but they forget to change the sign into cos. Yeah, so be careful for this one. Cos 60 equals to half. That means sine 150 degree equals to positive half. It's the same with the previous answer, so do not worry, you can use the other methods also. Okay, how about this? Cos 240. Cos 240. 240 lies in the third quadrant. That means the nearest boundaries will be 270 degree. So 270 degree minus 30 degree equals to 240, and the cos in the third quadrant will be negative, so I will put the negative first, and then I will ignore the 270. The cos will become sine because we use 270 degree. That means sine 30 degree equals to negative half. So cos 240 degree equals to negative half. Next is tan 300. Tan 300 lies in the fourth quadrant. That means the nearest boundaries is not boundaries, benchmark is 360 degree. It will be minus 60 degree to become 300. That means in the fourth quadrant tan will be negative. I will put the negative first, and then I will sorry, we have to use the 270. 270 degree plus 30, my bad. And tan will become cotangent, and 270 is erased. That means negative cotangent 30, because cotangent is the inverse of tangent. That means 1 over tangent 30, and 1 over tangent 30 is square root of 3 over 3, and then you can do the flip, 3 over square root of 3. We cannot leave it like that, you have to rationalize it like this, so you will have negative square root of 3 as the answer. Okay, next is simplifying trigonometric ratios in any angles. Example, question 1. Simplify cos 180 degree plus alpha. Okay, so first, to simplify this form, we have to determine the quadrant for the angles. For the angles, it's not given to you the value, but it's only like 180 degree plus something. So we can determine these angles by take a look at the quadrant. In the quadrant, we already know that 180 degree is in between of the second quadrant and also the third quadrant. That means if you add something to the 180 degree, it will go to the third quadrant. Yeah, I know, of course it can be also in the fourth quadrant, but we will take the nearest quadrant, so we can assume that this one is the third quadrant. Okay, so later we will have to determine the value, the sign of the cos in the third quadrant, which is negative value, and then as usual we can ignore the benchmark, and then the result will be negative cos alpha. Okay, so cos 180 degree plus alpha will be equal to negative cos alpha. There you go. Next, example 2. Simplify sine 270 degree minus alpha. Okay, first we have to determine the quadrant. 270 degree is in between of the third and also the fourth quadrant. When we reduce the 270 degree, it will go to the third quadrant. That means this one also in the third quadrant, just like that. And then we will determine the sign. For the sign is negative, and then we will erase the benchmark. And then do not forget, because we are dealing with 270 degree as the benchmark, that means the sine have to be converted into cos, and then we remove the benchmark, and finally we have negative cos alpha as the result. Example 3, we have tan 360 degree minus alpha. 360 degree is right here, because we reduce the 360 degree with something. That means it will go to the fourth quadrant, and therefore the angle is in the fourth quadrant, and also tan in quadrant and in the fourth quadrant is negative. We can remove the benchmark, so we will only have negative tan alpha as the final result. Next, example 4, cotangent 270 degree plus alpha. 270 degree plus alpha will be in the fourth quadrant. Cotangent is just like tangent. That means in the fourth quadrant, cotangent and tangent will be negative for the value. And then because we are dealing with the 270 degree, the cotangent will become tangent later, yeah. So it will become tangent, and then we will write down the alpha. For this one, 180 degree subtracted by something, it will be in the second quadrant. Tangent in the second quadrant is negative, and then remove the benchmark. Because we use 180 degree, the tan will become the same, 10. So for this one, it will become negative 2 tan alpha. Okay, next, example 5, given that sine alpha equals to 2 over 3 and 90 degree less than alpha less than 180 degree, this sentence tell us that the angle is in the second quadrant, because it's in between of 90 and 180. Yeah, so first I want to prepare the value of the cos and the tangent first, because we don't know the angles. That means we have to prepare the cos and the tangent first by using the right triangle. Okay, so this one is the opposite, this one is the hypotenuse. That means this one is 2, this one is 3, this one is square root of 3 square minus 2 square equals to square root of 5. Okay, let's prepare for the cos alpha and the tangent alpha. Okay, cos alpha first, because it's in the second quadrant. That means the cos will be negative, the tangent also negative. Cos is adjacent over hypotenuse. That means square root of 5 over 3. Tangent is the opposite over opposite over adjacent. That means 2 over square root of 5. Okay, next is to answer the question. The question says sine 180 degree plus alpha. 180 plus alpha will be in the third quadrant. That means for the sine it will be negative, and then we remove the benchmark, so we will have negative sine alpha for the result of the first expression. Next is negative cos 360 degree minus alpha. This one is in the fourth quadrant. That means cos in the fourth quadrant will be positive, and then remove the benchmark, you will have cos alpha as the result over tan 90 degree plus alpha. 90 degree plus alpha is in the second quadrant. Tan in the second quadrant will be negative, and then remove the 90 degree, the tan will become cotangent because we use 90 degree as the benchmark. Okay, next is to input the value. The sine is negative 2 over 3. 2 over 3, but we have negative sign at the front. This one is negative cos. Cos will be negative square root of 5 over 3. That means negative, and then also we have another negative. Negative cotangent. Cotangent is the inverse of tangent, so we only have to inverse the value of the tangent like that. Next is to simplify the value. So for this one we have negative 2 over 3 plus square root of 5 over 3, and then over square root of 5 over 2. Let's hope I don't make any mistakes. Yeah, this one is 180, right? Okay, 180 will become sine, cos will become cos, the same. Yeah, okay, I think it's correct. So next, let's try to make the denominator equal. For the top, it's already equal, so I can write it as -2 plus square root of 5 over 3, and then this one considered as division, right? That means I can make it into multiplication, but I have to flip the denominator like this. Okay, and then just multiply. We have -4 plus 2 square root of 5 over 3 square root of 5, and then we have to rationalize it. Square root of 5 over square root of 5, that means I will have -4 square root of 5 plus 10 over 15. There you go. This is the final result. Next is negative angles. Sometimes angle can be in negative value. What is the meaning of negative sign in angles? For positive sign, the angles is measured from the x positive axis right here. This one is the x positive axis, right? And then you will move counterclockwise for the positive angle. Okay, let's say positive 120 degree. You will move it like this, counterclockwise from the x positive. For the negative value, you will move from the x positive also, but this time you have to move counterclockwise. Clockwise. I mean, clockwise as far as 120 degree. So negative 120 degree, 120. Oh my god, so sorry, it's too fast. Negative 120 degree will be in the third quadrant. Positive 120 degree will be on the second quadrant. Okay, so that is the meaning of negative angles. Next, to calculate the result of trigonometric ratio of negative angles, we can make it into positive first by adding the angles by 360 degree. Okay, because 360 degree means one rotation, it will not change the value of the angle itself. Let's say we have sine negative 45 degree. So as we can see, the angle is negative. To make it positive, we only have to add it with 360 degree, add it with negative 45 degree, so we will have sine 315 degree. And after we have the positive angles, we only have to calculate it like usual. 315 degree is in the fourth quadrant. Sine in the fourth quadrant will be negative, so I will write down negative first, and then I will write down the sine 360 minus 45, right? So it will be negative sine 45 negative square root of 2 over 2. There you go. Okay, next example question 2. Tan negative 330. Because it's negative angles, we have to add it with the 360 degree. So later you will have the positive angles like this, tan 30. So tan 30 we don't have to use quadrant because it's in the first quadrant. So I will have the square root of 3 over 3 from the table. Okay, example 3, cos negative 150. The same, we only have to add it with 360. So you'll have cos 210, I guess. 210 is in the third quadrant. Cos in the third quadrant is negative, so I will write down negative first, and then subtract it with the 180. You will have cos 30 equals to negative square root of 3 over 2. There you go. Next is angle more than 360 degree. To calculate the result of trigonometric ratios of angle more than 360 degree, we have to subtract the angle with the closest multiple of 360 degree. What is the meaning of angle more than 360 degree? That means the angle is already rotate like one rotation or maybe more, 2 rotation, 3 rotation. Yeah, for one rotation, that means the angle will be greater than 360 degree, because one rotation is 360 degree. For 2 rotation, that means the angle will be more than 720 degree. Yeah. Okay, so to make the angles what is it called, smaller, we have to minus it with one rotation or maybe 2 rotation or maybe 3 rotation, as far as we can do it. Like 450 degree can be minus with 360 degree, one rotation, so you will have sine 180 degree. 180 degree is in the second quadrant. Sine in the second quadrant will be positive. You write down the positive first and then minus it with 180, so you'll have sine 0. Sine 0 equals to 0, so sine 540 degree equals to 0. Next is cos 870 degree. You can minus it with, oh my bad, actually the concept is not like that, but yeah, you can do it like so. Minus 360 degree, minus 360 degree until you cannot subtract it with 360 anymore. So you'll have cos 720 150. Yeah. Okay, after you have the smaller angles, you can use quadrant to calculate the value. 150 is in the second quadrant. Cos in the second quadrant will be negative. I will write down the negative first, and then 180 minus 30, right? 3 negative cos 30, negative square root of 3 over 2. Okay, I think this one is the last one. Tangent 3840 degree equals to tangent. Okay, for this one, if we do it like previous question, it will be a little bit painful because we have to minus it with 360 many times. That means we can just do it like this. We find the numbers that is multiplication of 360, that is the closest to the 3800. I think it will be 10 times 360 degree. Am I right? Because it's 3600. That means you will have 10 240 degree as the result, and 240 degree is already in our quadrant. That means we can find the result directly. 240 degree is in the third quadrant. Tangent in the third quadrant will be positive, and then we minus it with 180. You will have 60 at the result, so tan 60 is square root of 3. There you go. This is the introduction of our chapter in the second semester. I hope that you can understand it well, and next time we'll go to the harder section of this chapter. Thank you for listening. Bye guys.